rise, we unite from the mountains to the sea. Warriors of love, you and me. We are the new tribe of the earth.
Good evening and welcome once again to Rainbow Warriors 101, where we come together as one, all nations, all people from around the globe, working together as we enter the new earth. We are the change. We are the prophecy of the Sioux, the Cree, and the Hopi. And not only them, the rainbow prophecies are of many nations around the world. And I'm most honored to have been chosen as a global Rainbow Warrior Peace Chief. And with that, I'd like to start this with a prayer. Creator, we come before you this day, and we thank you for this day and the blessings of being here another day. We call upon Brother Eagle to give us sight as we learn here tonight, that we take this knowledge and we be able to go beyond and to use it. And Brother Wolf, that we able to walk this earth and use what we learn and not do damage. And to bear, that we come together with strength and unity, holding together as one. And to Buffalo, those things that are spiritual. Let us keep our focus on who we are and that we are here in this time, in this season, as chosen and have been chose to be here. All right, guys, this is a treat. We have 3 Agro-Scientists in this room this evening. And we're all about cleansing, cleaning up Mother Earth. Dr. Will's not in here tonight. He has been involved in remediation, soil cleansing at White Pine, California projects, cleaning up toxic dumps. He and Lance are working on enzymes that literally takes the heavy metals from the soil that will remove the Roundup and neutralize it, turn it into worm food. And the last few weeks, we have been learning how to grow and stimulate our plants using natural resources. We cannot be any healthier than the plants that we eat. And we have an epidemic now with autism and all kind of other issues all across America because of all the additives that have been added to our food. Part of the process of dumbing it down and part of the process of corporate greed. So we're taking it back, one garden and one farm at a time. And with that being said, I'm going to call on Brother Don to step up, and we're going to turn the program over to Don. Thank you, sir. Taking it back, one garden and one farm at a time. And with that being said, I'm going to call on Brother Don to step up, and we're going to turn the program over to Don. Thank you, sir.
Thank you, Chief Mel. First of all, thank you for allowing me to share today, Chief Mel, and to everyone. Just a short background. I started out professionally as a pastor, and we hit tough times with Carter's recession, and so I went back to what actually paid for me to go to school, and so I went back to that and got involved in humic and fulvic acids, and never looked back. To be honest with you, I spent the last 40 years or so in various and sundry humic acid formulations. And so what we're going to do today, based upon what I was asked to do, was just provide you kind of a beginning stage of an introduction of these products. So what I'm going to do is just go actually slide by slide, because if there are questions, I'd prefer to just answer them then and see what kind of discussion comes out of that. So first of all, humic chemistry. What are humic acids? We start with this green box here. anything that is organic matter can become humus. And as you see, the point that is fully decomposed is called humus. Out of humus comes the point that is soluble in terms of products and the point that is insoluble called humin. Forget that for right now. We want to deal with the soluble portion of that. Humic acids is an incredibly large family of organic molecules that, as you'll see in just a minute, run anywhere from almost just totally minute size to some really large organic molecules that help the soil hold together. And I'll show you where they have value in each and every one of those. The point that is soluble in just a high pH is called humic acid, or actually, well, that'll do for now, humic acid. The fulvic portion is that which is very small in molecular size, and it's soluble at all pH ranges. So just a point for in manufacturing basis, you typically use a high pH material to solubilize all the humic acids, and then you acidify that if you're after just the fulvic. The black stuff, the humic black stuff, will fall to the bottom of that tank, and you'll be left with this nice clear yellow liquid.
Don, let me back up for a minute.
Sure.
What we're calling humic acid, humus, and organic soil matter is really what people might be familiar with as peat soil instead of like a sand or a clay.
Or a compost.
Or compost. Yeah, or compost.
Mm-hmm.
Okay.
Yeah. Peat does fit really well in terms of a manufacture of this type of product. All right, I'm going to go forward. So we're starting with soil organic matter. Eventually we get to soluble humic acids that breaks down into two major components, humic acid and fulvic acid. I wanted to say one last thing about this. This is not your typical science definition. This is a procedural definition. You start with organic matter, that forms humus, that makes humic acid. The portion that is soluble is this whole consortium of organic compounds, and that breaks down into humic acid and fulvic acid. This is why this product has had in the past a real snake oil image. I grew up during that snake oil period of time and fought many battles over this. And so it's because there is no true definition that you have a certain structure and a certain amount of carbon molecule or carbon chains and that type of thing. This is procedural. That makes sense? Okay, I'm going to go on. So here's what the product looks like. Humic acids under a microscope. This is a scanning electron micrograph at 35,000 X. As you can see, some of these has sheet-like groupings. Some are more stringy, and this tells you how this is a wide consortium of different soluble humus molecules that has the definition of humic acid. But you can see how they form sometimes chains like this one in this particular graph. Very interesting product, if you ask me. Oh yeah, I forgot we had this. So in order to separate these out, you have to deflocculate them and allows it for the plant to be, or for it to become biologically active for plants. Here's what this looks like in chemistry. Now, it doesn't matter whether you're a chemist or not. There's some basic things that to know and understand in this. First of all, the carboxyl group, COOH. The hydrogen dissociates and you're left with this oxygen, which forms cation exchange capacity. Same thing with the hydroxyl group over here, the OH. Again, the hydrogen disassociates, and this becomes cation exchange capacity. So cation exchange capacity means other minerals that have a certain charge will be able to attach to here and be more available for the plant to use it. It's kind of like what we've always wanted. We want things to be, Chief Mel, like you've said, to be organically usable. And this is taking some of that organics and allowing it to be usable, even if it's not even if it's a fertilizer. You can use fertilizers, mix it with these products, and get some semblance of being organic. The benzene rings are the backbone for these products, as you can see. And there is one other cation exchange capacity site here, and that's this ketone, or it's called a quinone double bond O. And all things, there's an amine that will show up in these products. Now, you may know amines as being biologically active in and of themselves. And as true as that is for humic acids, they have biological capacity for both plants and your microbes. All right, I will move on. So you find these products everywhere. Everywhere where there's organic materials, there can be humic acids found. The product that I used for many, many years was found in the New Mexico, up in the high Rockies, and there's a tremendous amount of coal up there. But some of the coal has become closer to the surface of that area, and it becomes oxidized. And so what you get is a material that's called leonardite. Leonardite is called leonardite because it's a Dr. Leonard that first discovered it. So the leonardite has no fuel value because all of that oxygen has been incorporated into that product. You might remember the last slide I showed you how much oxygen was there. And that is a good thing for regarding to making humus into a soluble type product. Now, the other funny thing about this is kind of an odd graph. So I've got 4 different sites, a New Mexico site, an Idaho site, a North Dakota site, and actually a Utah site. All of these products produce a leonardite material that has various, various values and properties that make it either really valuable or somewhat valuable for growth in plants.
Don,
yeah.
can I ask you a question that might
Absolutely.
reflect for everybody? So you have these coal mines, basically. You have these places that people would, harvest coal, or they would be able to harvest this carbon, which is what we're talking about.
Yep.
Similar to what people do when they make biochar, except it's much, much smaller, much more easy to transport, and even the fulvic that comes off of it is even like little eyedroppers to an acre versus, putting out biochar per acre. Is that a good summation?
Yeah, it is. And actually, many times a leonardite could be substituted where biochar has been recommended to help clean up the soil, that type of thing, Lance, because it will do a number of things to help the soil. It's going to, first of all, help charge the biological life within that ground. It's also going to help provide a home site for that biological life. And it's also going to actually adhere to some of the impurities within that land, like a biochar would, for example, Lance.
Yep.
And make or activate a charcoal and make it usable.
Very good.
Okay, thank you for doing that. I really appreciate that because if we go this fast, I'm going to be done too early. So, all right. Any more questions? All right. So, The New Mexico is the thing that I use, and you can see this is the size of the molecules in a weight that's called Daltons. Dalton is the weight of one hydrogen ion. So these very, very small ones, they get into the plant like crazy because they're so small. But when you start getting up into the 10,000 Daltons, 50,000, 100,000, it's going to contain still some plant value, but the soil value is going to become even greater. So like you can see this one blue line, this product from North Dakota is primarily used for soil remediation. The New Mexico one is used for both, for plant activity and also soil activity. The Idaho one, really interesting, unique property. It's actually called blonde leonardite because it's so high in its fulvic values. What are some of the benefits? There's three categories of benefits with humic materials. First of all is physical, and that has to do with the soil properties. It's going to reduce crusting. It makes the soil more friable with less clods. I will tell you, I've seen this in action I worked with a chemical distributor in the west side of California. And one morning he called me at 5:30 in the morning. He always did all of his work early. And he had quite a mouth. And he said, Don, he said, I can walk on this soil with my bare feet if I wanted to. He said, what did you give me? And so I told him, he said, will this actually do that? I said, absolutely, it's going to do that. Now, each soil is different. So I'm creating overall things that help in this product, but every soil is going to be different. I always have to give that as a parameter. It improves water penetration. I'm going to show you that in a minute. It conditions the soil for better water utilization, and it helps in the development of that water stable aggregate. There's a book out called Humus Chemistry that I bought when I was poor, and back then it was $200. God knows what it probably is now. But in one of the chapters of the author Stevenson, he talks about the organo calcium clay consortium. In other words, you put those three things together. Now, the organo is the humic acid. It works with the calcium and it works with the clays in the soil to build better soil structure. All right, that's the physical side. There's also a chemical side. It's going to improve nitrogen uptake. It's going to make phosphate more available. It's going to help with potassium. It's going to complex and chelate the micronutrients. And interestingly enough, it's also going to buffer the toxicity of salts and heavy metals. I'm going to actually show you a short study done on humic acids reducing the toxicity of aluminum that had become inherent within somebody's soils. Then there's also a biological aspect. Now, the biological, remember the portion that was fulvic? That's those smaller organic compounds that can enter into the plant almost immediately and create changes. How does it create change? It creates change through genetic switches. In other words, opening up a plant's genes that will help in a certain area. And I want to give you an example of that. I worked with a product that literally was put out at about an ounce per acre, but it had all these very, very small fulvic molecules attached to it. And what we were looking at in this certain design was looking at salinity, reducing or mitigating the salt impact on plants. And so the researcher put the product out on this field, treated and controlled several different places. And he made this one interesting comment to me, to us as a group. He said, look, he said, you can see how your product mitigated the salt stress. And I said, John, help me out here. We're putting on about an ounce per acre. We're not mitigating anything. And he said the most fascinating thing to me. He said, you're right. A better way to say it is the plant has the resources within itself to mitigate salt stress. But it has a library of 40,000 genes, and it can't access all of those genes or that genetic expression at once. He said, your product opened up that gene or group of genes to help the plant access its ability to mitigate salt stress. That tells you something about about all living things, let alone plants as well. They have untold resources that are sometimes untapped because nobody knew how to open up that library book for those set of genes that would help in certain areas. So in that biological, we're going to improve the seeding establishment. This is really important, and it happens with all Fulvic products that I know of. It proliferates the root and shoot development, and primarily, first of all, the root development. Sometimes I have seen over a 100% increase in root development with the addition of adding fulvic acid to it. It also stimulates the biological life within the ground as well, and within the context of that whole life system of whatever biology microbes are there will be affected by these products. I'll show you a great example of that in a few minutes. Any questions?
Don, why would you have higher yields and higher quality both?
Great question. The first is that this root development, Lance, as you well know, produces better quality and better yields because now that plant has access to more nutrients. It has better access to more water. I could go on with this. Do you want to add to that, Lance? You're well.
Well, yeah, one of the main things of the plant is the roots are the brains to the plant, as we used to say. And a lot of the movement and up and down within the phloem and out through the xylem is movement of nutrients that are being brought in that are needed up in the top part of the plant. There's a number of different things, but if you look at the two systems, you have the phloem that gets photosynthesis, moves the sugars down to the roots. So if you don't have enough roots, it's going to get locked up in the stem. What we see is that the roots are really the most important aspect early on. So sooner or later, you get to where you're setting fruit, and then the fruit takes over like a infant would as unborn child and starting to take everything out of the mother. But the idea is that the root system itself, if you don't get a well-established root system, you'll never have the genetic potential to increase yield. And so we really find that with these products, the fulvic and the humus and the humic, all of them, humic acid or the humus, but the fulvic acid really drives the roots. And that's the one thing I've learned through all these years is that small thimbleful per acre is making almost double the roots. Many times we've seen that and been amazed, so it's a powerful singular group of molecules that are so small, they get into the plant quickly and they help the plant build its root system fast, which is what's necessary to hold the structure.
Yeah. Well put, Lance. I appreciate your being involved in this. Thank you. All right. Also, interestingly enough, Leonard, I mentioned to you before, but humic substances in and of themselves do have the ability, especially particular ones, the New Mexico one in particular, to adhere to the surfaces of sand. And what does that do? That again adds to the cation exchange capacity, the ability for that soil to hold nutrients and make them available for the plant's use. Now, the one disadvantage of this, for example, if some of you have a drip irrigation, and you're feeding your plants through that irrigation system, you don't want to put the humic through that sand filter because it could potentially plug that up. So other than that, this is a tremendous advantage. I work with these some of these soils in Florida. They're basically beach sand, and we could see the value of those types of things. Okay, I get to move on. This is just a summary of the different nutrients, but you can see the nitrogen, the phosphorus, the potassium, calcium, magnesium, all of these have a real advantage with the use of humic. The only one that is a little bit still uncertain is manganese. But this is a chart that's summarizing 27 published studies on humic acid and nutrient uptake. So you can see there's a tremendous advantage to using a humic product in relationship to your fertility of that plant. Lance, I don't mind. You want to add anything to this one as well?
The only thing I would mention is that, believe it or not, since Don and I started in this business, normally fertilization was like NPK. Maybe somebody knew a little bit about calcium, and certainly there were a lot of studies being done. But today, as we've gone over the macro and micronutrients, what's so impressive about using fulvic acid and humic acid, but fulvic acid has an affinity, as you can see, for all of those nutrients, and in particular, the small ones that really get redirected and pulled through into the plant when you think about things like zinc or iron or manganese or calcium, sulfur. These things are so small they can get lost. But if the fulvic acid is part of the solution, whether you add it to it when you put it out or you put it into the soil and it's loosening up those micronutrients, that's what really allows the fulvic acids really allow these minerals to get up through the root hairs. And it's extremely impressive. I mean, we've done a lot of studies where we can measure this almost to a 40% yielding. I mean, a 40x increase in some of these nutrients, believe it or not.
I mentioned to you that humics will detoxify heavy metals. So this is a study that was done. And you can see here's the rate of humic acid that was allowed at parts per million. So here is no humic acids. And you can see as aluminum was added, soil medium, that growth medium, the results or the growth potential of that plant, in this case it was corn, went down significantly. When you add humic acids, you did have a decrease at the lower rate, the 100, but it did level out. It did not continue to decrease. And then at the 300 parts per million, you saw that actually maintain and have no ill effect on that aluminum toxicity. And this is true not just for aluminum, but cadmium, which is also present in some fertilizers. You would see the same thing in high salt content, as I mentioned to you before. So it does really some really interesting things. Lance, you want to add anything to that? No answer. So we're gone.
No, I'm good. I'm good. You're good.
I mentioned to you this already, but just a reminder, here's the things that make your soil structure. The clay mineral. So this is an incredibly thin sheet of clay, and you add to that calcium, and you add to that an organic molecules like the humus, and that makes your soil structure. That provides air pockets for that soil structure. Soil does not want to be compacted. The plant does not want it to be compacted. It wants that air pores, that air to be viable down through that plant, through that soil. And that's what makes for a good soil, that soil structure. So again, I mentioned to you this before, that's out of this book, Humus Chemistry. And it's a great book if you want to be able to sleep at night, because, unless you're a true scientist, you're going to fall asleep. But it's got a lot of great information about humus. Lance, you want to talk about soil structure at all anymore on this one?
Well, most people know that depending on where they're at, particularly in the South or particularly in certain areas, you have desert soils that are sandy. You have a lot of clays, I mean, Georgia clay and different things like that, where you can't be as efficient as you would in a moderate soil that would have a good structure, that would have a little bit of clay, a little bit of sand, and
What they would call a clay loam.
so yeah, clay loam, yeah. And loamy sand is really the one that we all desire, but very few of us have that luxury. So what the Fulvic and humus does, as most of you that are farming and even your backyard gardens, you know that when you add humus to the soil and mix it up, it starts to loosen up. It holds water. It has porosity so that the roots, I'm sure you know this, but if you don't, the roots go into the soil pore. And if the pore is full of water, it's not able to draw that out. It's only able to do that when the water film remains and the water leaches out of the pore. And in that film is where you're finding the nutrients and the things that are in the pore that the root pulls out. So, even though you have a saturated soil, that plant isn't pulling that water up until it leaches out. And so if you've leached in some of these nutrients because of fulvic carrying them into that soil pore, it's going to remain in that film and be pulled out. So that's why yeah, Harley, I'm sure you could talk to us about that later as well, but that's one of the principles of, you don't want you don't over waterlog the soil, and it's hard not to do that with a clay soil. So this is how the humus and the fulvics help.
And not only that, Lance, but just one last thing on this is that this also is providing benefits for the biological life within that ground.
Right.
This helps provide that healthy soil.
There's a relationship with the bacteria and the fungi and all the good things.
All those
good
things. And as you can see, the addition of humics will reduce the erosion of the soils. I'm just gonna leave this one alone, Lance. I'm gonna go to a better slide that provides some actual data on how well this can work for you.
Sure.
So this was some studies in Italy where they added more leonardite. So they all started here, and the soil aggregate size increased with humic applications. And that is just what we're talking about. You're looking for that aggregation in that soil to create soil structure, to provide a place for the biological to live, to make it easy on the roots of the plant, and the whole 9 yards. So great study here. It's done by one of the real humic stars, a guy named Piccolo. You'll see a lot of research that this guy has done. This one is obviously kind of old, but it's still viable. And then I want to just show you one thing that we did in a company I worked for about 38 years. Is we worked with a company in Washington where they were very detail oriented and they kept track of everything. And so we asked them to do treated and control and keep track of those records using the leonardite and using the liquid humic acids. At the end of 1 year, they had about a 5% reduction in water use with a same value in terms of yield. At the end of 2 years, that came down to about 80%. And at the end of 3 years, they were using 15% less water with the addition of humic acids on an ongoing basis, both in the dry product, which is the leonardite we've talked about, as well as liquids. This is a huge thing for the West, for us in the West Coast here, because water, thank God, we've had some great water years lately, but we've had some real desert years as well. where things were really tight, water-wise. Lance, you want to add anything on this one?
No, thank you.
All right. I talked about the value of these products with plants. This is a study I did. It's just a treated versus control with a grower in the west side of the San Joaquin Valley, which is where I live. I live in Modesto. And this is a cauliflower farmer. And so what he would do he would plant close plantings, all of his cauliflower plants, and then he would go out at a particular time, and as you can see, just plant these. I think it was every 12 inches or something of that end. The day he did this, the temperature was 105 degrees. And on part of his ranch, he water ran the humic acid down this furrow. And you can see these plants are standing up. On the control side, they're wilting. In fact, they did make it, but they always showed that line in the field because of that initial bump in the issue they had with the heat of that day. There's another thing that takes place in this that I wanted just to point out to you, and it's part of the reason these plants look so good shortly after they were planted and then had the humic water run over it. Plants respire, and they do so primarily through a stoma, which is a hole underneath the leaf that provides respiration. One of the values of humic and fulvic acids is that almost all of them will partially close that stoma in their presence. In other words, the plant takes up that product and it's going to close that stoma partially. Not completely, but partially. And so therefore, its respiration is going to be impeded a little bit, which is what you see right here. The plants had enough moisture stay within that plant that it looks good, as opposed to these that are wilting horribly. So
And Donna, make an extra mention. People probably know that we get carbon from the CO2,
yeah,
and that stomata has to be open for us to be able to get that in there. When it's
yeah.
wide open and it's respiring, there's a push in the opposite direction. But at least this scenario you're giving. But the one thing that's interesting is when we close the stomata through the use of humic fulvics to a maybe 20%, maybe 30% open instead of 80% open.
Yeah, exactly.
Still enough carbon exchange without it all pushing out to actually continue to build the structures in the plant and not lose that day, not gaining, more carbon for, lumber to build the house, so to speak.
There you go. Thanks, Lance. I appreciate you being along because you're the technician. I am the salesman.
Well, and Harley's the doctor. So,
Oh,
we'll
okay.
hear from
Harley,
him
we
eventually
should have
too.
you talking in here somewhere. This one I included just because some people can't get their arms around the fact that these things will improve the biological life. So this was way back when. This is probably a stuff I did at least 38 years ago. We'd run into these dairy farmers that had these lagoons, and sometimes those lagoons would start to deactivate. In other words, they would get layers on top. They wouldn't be active in terms of what you want in like a septic tank, where the biological life is running things around and it's keeping everything viable. So we did this. We would say, "Hey, you want some help with that lagoon?" And we would throw the Leonardite in, then we back it up with some humic to begin that, and we began to see major changes. In fact, I usually help the guy. I'd be out there slinging Leonardite into his lagoon, and by the time I got around that whole lagoon, which is usually about an acre and a half, it was already starting to churn. It was already changing the dynamic, and that biological life was taken off. It's really cool to watch. And of course, in the lagoon, what you're after is better odor control. You want that lagoon to become healthy so that when they put that lagoon water out on their plants, it's not going to be an issue. So all that to say, these things do provide biological activity. In fact, one of the things we used to do, we used to have septic tanks everywhere here in Modesto. I'd give all my neighbors a little bag full of leonardite material, and I'd say, throw a teaspoon of this in every so often. Again, to help that biological life in that septic tank. We were talking about root development. So I thought I'd show you this hydroponic study that we did. Here we have the control. Here we have Fulvic at a low rate, and here we have Fulvic at a high rate. A better way to see this would be the next slide. So you can see this is without the Fulvic. You can see what kind of dynamic this did. But then look at this. Here's the root development on the control or the non-treated versus the treated. This was only with fulvic acid, and I'm going to explain to you why. They did try this with humic acids. And you know what happened? The humics in that hydroponic, because it's free flowing in the water, right? And the roots are all in the water. The humic was attracted to the roots. And eventually it coated the roots and the plants died because it coated them so heavily. So what we needed was fulvic, because fulvic would go up into the plant and help it in all sorts of growth ways. So you can see, Lance, you talked about sometimes 100% or more of an increase in roots, and this is at least that. This was actually about 3 times as many roots in a hydroponic setting, of course. So it's just water. As opposed to the non-treated.
Yeah, that's great.
Leonardite rates, many of you might want to try this because you have the small 2-acre farm or something like that. For turf, Chief Mel, I'm going to give all this to you guys, so you don't have to write any of this down. It's just you'll see these things when it's appropriate. And then for agriculture, 10 to 40 pounds per acre. For problem soils where there's like sodium or boron or other things, probably more in that 80-pound range has a value. And the same with sandy soils. There are some companies that recommend 200 pounds per acre. And to be honest with you, if you're doing it year by year, I think this is a better route to go. And humic acids, typically at 1 gallon per acre, depending upon the quality of the product, and I can help you in a sidebar sometime if you need any help with that, and the application rates. There's a number of ways you can use humic acids. You can add it to the liquid fertilizer. Always pre-mix it to make sure that you don't end up with a gummy smear. You don't want that to be in your irrigation. You want that to be done ahead of time to make sure it mixes okay. I've done water runs in a number of different ways, but again, as I mentioned to you before, that water run after the sand filter, because sometimes certain humic products will be somewhat attracted to that sand, and again, it'll create an issue that you have to go in there and clean out.
Don, explain a sand filter for everybody, just in case.
Oh, okay. So in drip irrigation or even in sprinklers, they will want to run their water through a sand filter, so it takes out all the things that are floating around in that water. It could be
junk. Yeah.
Junk. Yeah, exactly. So in this case, you still want to have the sand filter, but put the humic in after the sand filter.
Meaning that the sand filter is ahead of it, the water's going through, collecting the junk, but you inject past the sand filter
at a later point. Yeah, exactly. You can use humics for foliars, but better just to use the fulvic acid by itself. It's a great foliar application product. Okay, hey, first of all, let me say, I appreciate this stuff. I've been doing this stuff for 35, 40 years, and it's been a fun ride. And here I am near a certain stage of life, and I still get excited about this stuff. So appreciate it.
Did a great job, Don, very much.
Well, thank you. I appreciate it.
Yeah.
Thank you. It's most appreciated. I know some of the words and terms go a little bit over my head.
Sorry about that.
I was sharing with, yeah, but with you, between you and Lance being able to play together, it helps bring it together better, and that I appreciate. And I'm going to tell you, I've been using what I have learned here in my garden.
Mm.
And I was giving Eric earlier a tour around my garden and my berries. They are nothing short of amazing. The growth, the increase. Eric, would you agree with that? The size, it's phenomenal.
I want to come down.
I hear you, brother. All right,
Yeah.
we're opening up the floor for questions. Please raise your hand if you have a question.
I
And
want to say one more thing, Chief Mel.
yes, please.
Some of you will say, how can I get a hold of these types of products?
Sure.
I'm working with Lance right now on something he's doing within his company. And so I'm going to sort out this company that he's with and probably have Lance provide that information to you at some point, Chief Mel.
Very
Yeah,
good.
we'll
And
get to that.
yeah, and we're going to be setting up a doc center on Rainbow Warriors 101, and probably some on our light streamers for our Rainbow Warriors there. So we're building a database platform because, like I said, it has to start with gardens and
Yeah.
farm.
Could we get Harley to be unmiked, Mel?
Yes, please, Harley, unclick. You open. There you go.
Harley, do you have any questions? You have any questions?
Yeah, I had one question along the way. I mean, I've loved using fulvic acid in my hydroponics over the years, even added it to some of my blends. But the question I have, does the plant actually absorb or take in the fulvic acid, or is it just transfer the minerals that are attached to the fulvic acid?
No, it actually produces, especially at the low molecular weight range, 200 to 700 Daltons. It's acting as a genetic
Switch.
switch to provide genetic switches,
Yeah.
to open up genetic so that it can address certain issues the plant faces.
So those large molecules could be transported into the plant, right?
Again, they're at the 200 to 400, the 200 to 700 Dalton range.
Yes.
Those fulvics will go right in. They will go right in and up and out throughout that whole plant. I was doing this one trial. I'm sorry to interrupt you. I was doing this one trial where we took a full vineyard vine about 6 feet long, and we dipped one leaf in a fulvic solution. And interestingly enough, the fulvics went both up and down to the other leaves within that vine. So that tells you how mobile they can be within that plant, both up and down.
Yeah.
Okay.
All right, Brother Eric, you got your hand up, sir.
We got to hear him.
Try and eat lasagna here too.
Save a slice.
Got it.
Oh, my mother, my wife just made this gigantic lasagna. It's like, I don't know, it's too deep. But I was just really fascinated about how the fulvic acid works with all pHs, because I know as a plant grower myself, that affects the absorption rate, and I think that was really neat. I'm kind of stuck on that one point. I really like that. Like, if I could get that.
Eric, that's because humics in general, the really big ones, they act just like a protein. In a high pH, they spread their wings.
Okay.
In a low pH, they curl up. Therefore, they fall out of solution. So the fulvic is so small, it doesn't have that capacity. It's just going to stay right there and be used by the plant.
Okay. Okay, that makes sense. That's awesome. Thank you.
Yeah, you betcha.
That's really awesome.
Any more?
As I had
Miss
as I
Harley?
had talked
Good.
as I had talked about the plant hormones and having regulation on the plant from soup to nuts, fulvics are very much in line with that. They actually play a major role in triggering the genetic expression of the plant, whether it's to regulate it during stress, which it does, or to regulate it for taking something and bringing it from the root all the way up to the shoot. So, compared to plant hormones, which have certain things that are being done, these fulvics are much more broad in affecting the genetic expression of the plant. I think that's the way to say it.
In addition to that, Lance, it's the root growth when in the presence of humic acids is tremendous. That by itself increases the uptake of nutrients into that plant. If you have a root here, like right here, obviously this is a bad example, but all this surface area is where the plant takes in water and nutrients. And so when you start to get 2x or more, the surface area goes up even more exponentially. And that creates such a perfect scenario for water uptake in the plant and also nutrient uptake in the plant.
Yeah. I just saw somebody mention fulvic acid spelled with an O, Folic. This is Fulvic, which is Fulvic. Not to criticize anybody, but I mean fulvic acid is also a part of nature, but this is a fulvic with Fulvic, which is much different.
And I think that what she had was referring to was concerning her soil down there in Florida. Miss Marcy had her hand up, so I want to get her in here.
Yep.
All right, Miss Marcy.
Hello, thank you. I just wanted to tell you three men, I thoroughly enjoyed your presentation because you each one of you played off of the other in information that's shared in a cohesive mental. Whoops, my phone's ringing. Anyway, I loved it. Thank you.
Thank you.
Marcy. Very nice. Very nice.
Thank you, Marcy. Thank you. I really appreciate it.
Anyone else?
I have a comment.
Please.
From what you're saying. And one of the things I think was a really huge benefit that maybe we didn't talk about too much tonight was the uptake of iron by the plant, because I saw it on your chart, and iron was one that was taken up significantly more with the use of the fulvic and humic acids both. But iron is a catalyst for chlorophyll production.
Yes.
So if the plant picks up more iron, it makes more chlorophyll. Makes more chlorophyll, harvests more light energy. Harvests more light energy, makes more sugars to grow and reproduce.
The plant is a factory, and there's no doubt about it.
I'd like to introduce Harley to the whole group. Harley and I have known each other for a long time, and Harley works a lot with container plants and greenhouses, but also is well known in many circles as being very knowledgeable about a lot of the things we're talking about today. And I asked him if he would come in and on his own time, which he agreed to, and talk to us next week about enzymes and things that, we've talked about the microbes and we've talked about, but what are they doing and how are they doing it? They're releasing enzymes that are affecting the plant. So, you can imagine, when you use accent and you put it on meat, that are enzymes that break down the protein, so it's available more readily, those kind of things. So he'll be with us next week.
Cool. All right, Miss Jessica.
Hello there, everybody. I really appreciate the presentation, and I'm glad that you guys make it to where, we can watch later. And I just want to say thank you, and I'm grateful. And if you pray, just keep me in your prayers. We've been sick, really sick the last couple days. So we had a good 5 days of none of it, and then just lost it all yesterday. So,
so sorry.
Yeah, but this is awesome, you guys. Please keep it up. I'm very grateful.
Will, who had been on earlier, Will Spencer, uses Fulvics along with some of the medicines for human and animal use as well. And that's something we haven't touched on. But Fulvics actually help get the vitamins and things if you add them, to like for if you're, you got calves or you have piglets or whatever, it really does help transport a lot of those minerals and vitamins. And we didn't even mention that, but it's for humans as well as plants.
That's awesome. The world, the world is one place. Mother Earth is her own entity. And I go battle with the religious people all the time because I tell them Jesus spoke directly to the fig tree, a knowing entity.
Yes.
He said the rocks will cry out and call him the Son of God. And they said, oh, that was a metaphor. I said, he didn't speak English. He didn't believe in metaphors. So I try to make it funny because,
Well, Creator said anything I can do, you can do in greater. Next.
that's right.
And
Amen.
next, there has been studies on the power of prayer.
Yes.
On many different topics. The VA did a study. It didn't matter what religion, whether you were Christian, Buddhist, Hindu, those that was prayed over healed quicker and used less medication. In Guatemala, I made reference to that in my book. They did studies with farmers coming together around particular fields. No difference in what was far as additions to the crop, but just over fields that they prayed over. The fields that they prayed over were healthier and more abundant and produced more income for those families. So I believe in that. It changes. It is about frequency. Prayer is called a conscious, willful intent. And we know the communications that go between plants. They talk between one another. A tree, as it is leaving this earth, it sends all of its nutrients, to surrounding trees.
Yes.
They all communicate. So there's a grander scheme that most people cannot even begin to conceive of. But when you know that this is within each of us, it gives us power to make this world a better place. Guys, I appreciate everyone being here tonight. You got a hand up, Eric?
Nope, just put my fists up in support.
Oh, hallelujah.
All right.
I'm with you, bro. All right, so we're going to wind down the recording side of this now. And we're going to just go to, as soon as I find out where the recording side is on this screen.
I just got back.
Oh, hi, Marcy. You got any more comments before we close this side?
No, but I just was throwing it in there that, shoot, you're all closing down and I just got back after my phone call.
Oh, we rise, we unite, from the mountains to the sea. Warriors of love, you and me.